Welcome, future calc students. Today's production is brought to you by yours truly, Kelsey Kaiser, and today we will be covering integrals as net change, or lesson 7.1. So far, we have used integrals to find area of a region and volume of a region revolved around a line. Now we will use integrals in a different way to determine net change over time. First, let's review what we should already know. That derivatives tell the rate of change. If f of x equals the value of something, then f prime of x represents the rate at which that something is changing. So for instance, if v of t represents the velocity of a particle at a particular time, then v prime of t would represent the rate at which the velocity is changing, or what we know as acceleration. Now, let's relate it to our lesson. Let's talk about integrals. If f of x equals the rate at which that something is changing, then the integral from a to b of f of x dx represents the net change in quantity from x equals a to x equals b. We are going to use this concept to talk first about displacement. Displacement simply means that if v of t represents the velocity of a particle at a given time, then the integral of a to b v of t dt would represent the net change in position from t equals a to t equals b. Then we will also consider that by adding displacement with the initial position of the particle, we can determine final position. So we are going to use these concepts to talk about our first example. If v of t equals 6t squared minus 18t plus 12 is the velocity of a particle moving along the x-axis when t is between 0 and 2, find each of the following. First, we are going to determine when the particle is moving to the right, to the left, and stopped. Next, we will talk about the particle's displacement for the given time interval. And if s of 0 equals 3, we are going to find its final position. And last, we're going to find the total distance traveled by the particle. First, let's talk about A. Determine when the particle is moving to the right, to the left, and stopped. So first, we are going to consider that v of t equals 6t squared minus 18t plus 12. The easiest way to find when the particle is moving to the right, to the left, and stopped is to first find when the particle stopped. To do so, we would set 0 equal to v of t, because when the velocity is 0, the particle will not be moving. So we are going to solve. We're just going to use simple factoring here. Plus 2. And you should be doing this along as well with me. 6 times t minus 2 times t minus 1. And by setting these equal to 0, we can find that velocity equals 0 when t equals 2 and when t equals 1. Next, we are going to plot the points of time when the particle stopped on a line of velocity. We're going to plot the points of the range, because time is between 0 and 2, as well as the points where the particle stopped, which is 1 and 2. And we need to determine when the particle is moving left and right. To do so, we need to find out when the velocity is negative and when the velocity is positive. When the velocity is positive, the particle will be moving right towards the more positive integers. When the velocity is negative, it will be moving left towards the more negative integers. So we are going to choose a point between 0 and 1 to plug in for our velocity equation. And I am going to choose 1/2, which is between 0 and 1, So I'm going to do 6 times 1/2 minus 2 times 1/2 minus 1. And we don't actually need to solve this problem. We just need to know whether it is negative or positive velocity. So we know 6 is positive, times 1/2 minus 2 is going to be a negative, times 1/2 minus 1 is also going to be a negative. Positive times a negative equals a positive. So the velocity between 0 and 1 is positive. Then we're going to plug in a point between 1 and 2. So I will choose 1 and 1/2. So we're going to do 6 times 1 and 1/2 minus 2 times 1 and 1/2 minus 1, which is going to be a positive, times a negative times a positive. So positive times a negative is a negative, times a positive is still a negative. Therefore, we know that the velocity is negative. Last, we need to piece everything together to write that we know that the particle stopped at t equals 1 and 2. Now we know also that the particle is moving left when the velocity is negative, which is between 1 and 2. So during the interval 1 and 2, notice that I used parentheses because the particle is stopped at points 1 and 2, so they are not considered to be in the frame of when the particle is moving left. And last, the particle is moving right from the interval 0 to 1, where the velocity is positive. So that is it. That sums up A. Now, we will consider part B. Find the particle's displacement for the given time interval. So let's go back to what displacement means. If phi of t represents the velocity of a particle at a given time, then the integral from a to b, v of t dt, would represent the net change in position from t equals a to t equals b. So, as we apply that, first we are going to remember that v of t equals 6t squared minus 18t plus 12. Now we are going to insert v of t into the formula for displacement, which we now know as displacement equals the integral of a to b v of t dt. So we're going to plug in what we know, which is, the integral between 0 and 2 of 6t squared minus 18t plus 12 dt. And we are going to use antiderivatives to solve this. So we know that the antiderivative is 2t to the third minus 9t squared plus 12t. And we're going to keep solving and plug in 2 and 0 to the antiderivative and subtract. So we're going to do 2 times 2 to the third minus 9 times 2 squared plus 12 times 2. I'm going to do this whole thing minus 2 times 0 to the third minus 9 times 0 squared plus 12 times 0. So we're going to find 16 minus 36 plus 24. Subtract, and we find that displacement is equal to 4. Now that we've done the hard part, we have to pull everything together once again. 4 is the displacement, so what is its final position? Final position, if we remember, is displacement plus initial position. So the simple part is we just have to add displacement of 4 plus the initial value, s of 0 equals 3. So we know that the initial value is 3. So added together equals 7 for the final position. And that sums up part B. Last, we'll tackle part C. Find the total distance traveled by the particle. This is a fairly simple problem. Now that it's a very similar concept to displacement, except we're doing total distance, not just the net change. So for instance, if we had a number line, and say our initial position was at 2, and the particle moves 3 to the right and 4 to the left, we would know the displacement would be -1 because the particle would now be here. So d would equals -1, but now we want to find the total distance. So it's like you're considering the -4 as a positive because distance is always positive. So basically we would just do the absolute value of it. So the absolute value of 3 plus the absolute value of -4, which equals -7. So by using this concept, we're going to apply it to our problem. We are just going to use the integral, the same one that we used for displacement, of 6t squared minus 18t plus 12. I'm sorry my handwriting's so terrible. dt. And the only difference we're going to do here is take the absolute value of this entire thing. Now we already solved one with antiderivatives, so I think we should all be fine to use math option number 9, or nderive, and plug in this formula. Do not forget to do the absolute value of the entire thing, however. So we're going to plug in 6t squared minus 18t plus 12 dt, and we get our final answer of